Welcome back to True North Mechatronics. In this episode, we are designing the battery box sides. These are the main structural components of our upper assembly. We're carrying over the truss pattern from our vertical frame rail to maintain both lateral rigidity and aesthetic continuity. To assemble the box itself, we're engineering a robust tab and socket system using 3 rectangular pockets for both the top and bottom edges of these panels. Because the bottom is screwed to the deck, we will map out screw holes in the top left and right corners that will connect to the mounting bosses on the upper plate. Design, engineer, deploy. Let's get to the CAD. Begin by creating a new body and a new sketch on the XY plane. And we're going to use the polyline tool, and we're going to map out the basic shape for our batter box side. We're going to dip below the x-axis here, and we're going to come in like so. There we go. All right, so now we're going to set the lines that weren't automatically horizontally or vertically constrained so that they are horizontal and vertical. We're going to make it so that these two peaks here are symmetric with respect to the x-axis. And we're going to set the width of this inset to 3 millimeters. And we'll set the width of this point here, which will connect to our mounting bosses. We'll set that to 8 millimeters. All right, and now we're going to set the length of this line to 68 millimeters. Drag that down so we don't lose track of our feature there. Going to make it so that these two edges here are equal in length. And we're going to also set this edge here so that it's symmetric with respect to the x-axis. All right. Now we're going to set the length of this vertical inset line to 19.9 millimeters. And we'll set the length of this inset edge to 78 millimeters, leaving just this bottom edge here to constrain at 57.5 millimeters. And so with that, we've fully constrained the overall outline of our battery box side. Close out of the Sketcher workbench. And we're going to pad this out to 3 millimeters. And now we will create a new sketch on our top surface here. And we're going to add some anchor points, top left and top right corner of this part. And we're going to constrain these so that they are symmetric around the y-axis. Make it so that the diameter of both holes is equal. And we'll set that diameter to 2.8 millimeters. We're going to reference the top edge here, and we're going to inset this from the top by 3 millimeters. And we will bring it in to the center of this by setting it to 4 millimeters. All right, so now our anchor points that will connect to our mounting bosses on the top of our battery box have been fully located. And then we're going to create that rectangular slot pattern, and our logic deck will connect into this, as well as the battery box sides will connect into this socket system. We're just going to rough out 6 rectangles here. We're going to make this center rectangle so that it is symmetric around the y-axis. We'll do the same with the one below it. We're going to set the top edges of all of our rectangles so that they are equal to each other. And we're going to make the 2 outer edge triangles symmetric with respect to the x-axis. We'll do the same with the lower rectangles. And because we want these rectangles so that they are equal in their vertical dimension, we're going to set one side of each of these rectangles so that they are equal. And now that we've done that, we need to make it so that the center rectangle is collinear with the outside rectangles. That was the wrong tool. Let's try that again. There they are. So those ones are collinear. Do the same with the bottom ones. And now we have a group of rectangles on the top and on the bottom. Let's dimension those. These triangles are all going to have a horizontal width of 10.2 millimeters. That's because the tabs on the vertical or on the battery box top and the logic deck are going to have 10 millimeter slots, so this is a 0.2 millimeter overage. And let's also set the thickness of the vertical dimension, and that is going to be 3.2 millimeters. So again, it's going to be 0.2 millimeters over the 3 millimeter thickness. All right, so now what we have here is we've got a group of rectangles that move as groups on these top and bottoms here. We're going to make it so that the bottom rectangles are collinear on their edges. So let's do that. So now they will move as a group. We're going to set the distance from outside point to outside point of this group of rectangles to 74.2 millimeters. And now we're going to set the distance between the top group and the bottom group by their inside points there. We'll set that to 31.8 millimeters. We're going to use the external geometry reference tool. We're going to reference the top edge here. And we're going to offset this entire group from the top edge by 1.9 millimeters. Let's just organize our constraints here so we can see our values. Let's bring in that outside edge there. There we go. Okay, so as you can see, we are fully constrained here in the Sketcher workbench, so we can close out of this now. And we're going to pocket these shapes through. We'll accept a default of 5 because that's greater than the thickness of 3. We need to add a feature down here. This will be used for securing the battery box to the accessory deck. So let's create a new sketch on that. We're going to zoom in on the bottom here. And we're going to reference the upper edge here and the lower edge there. Using the polyline tool, we're just going to trace this bottom edge here. And we're going to come over and down. All right, we need to constrain this so that it is vertically constrained. And we're going to set the thickness of this portion to 9.5 millimeters. And this lower portion here will be constrained at 5 millimeters. So that's all we need to do here. We're going to extrude this out now. We'll pad it out to 12 millimeters. And now we're going to continue to build out on the very edge here. So left click on that edge, and we're going to reference the top and bottom of this ledge, and using our rectangle tool, we're just going to place a rectangle there. So we can close out of the Sketcher workbench, and we're going to pad this out by 3 millimeters. And now we're going to add a chamfer. So let's move around and look at our edge here. We're going to look at it from this direction. Let's grab that edge, and we're going to place a chamfer on it. And this one we're going to set by 2 distances. So our first size here is going to be 37.5 millimeters. And then our second edge will be 4 millimeters. There is our chamfer here on the edge. And the next thing that we're going to do is we're going to add that triangular truss pattern here. So let's click on the top face and add a new sketch. And we're going to use the polyline tool for this. So we're going to create 4 triangles. Make sure that you don't accidentally click on either the X or the Y axis, because your line will end up so that it is locked to that line. So I'm going to be careful not to click on it. We'll modify where these triangles are sitting in just a second. Let's begin by taking the bases of all of our triangles here. We're going to set them so that they're equal to each other. I'm going to do the same thing with the edges of the triangles. Set them so they're all of equal length. And now what I want to do is I want to make these triangles so that they're collinear with each other. I'm going to use construction geometry for this job. So I'm going to add a piece of construction geometry between all of the triangles here. Now these ones were automatically, they were horizontally constrained, so we're going to horizontally constrain this point as well. We're going to set the construction geometry so that it's all of equal length, and then we will set the width of our construction geometry here. We can set that to 5 millimeters. All right, now we're going to drag these triangles out and we're going to locate them on our main shape here. I'm going to reference the left-hand edge and right-hand edge of our battery box side. And I'm going to create an offset from the edge here of 6 millimeters. And I'm going to do the same thing on the other side. So we'll give that a 6 millimeter offset. Okay, there we go. And so now we're going to reference the top edge here, and we'll give this an 11 millimeter offset from the top. So now we've constrained the top of the triangles here. And our offset here from the bottom will be set to 27 millimeters. And so with that, we have we've created our triangular truss pattern. So it's fully constrained. We can close out of the Sketcher workbench, and we're going to pocket this through our shape. And with that, we're going to now add some cosmetic and functional fillets to our shape. So these ones up here, we're gonna fillet these edges. These are going to be mostly cosmetic. They're going to give a nice rounded shape on the top of our battery box. So we're going to add a 2 millimeter fillet to that. And we're going to come down here and we're going to add an 11 millimeter fillet to this. And then we want to add a fillet to this corner here. This is just so that when we are adding the enclosure to the back of our robot to cover our Vitronics platform, this will allow the Vitronics enclosure to slip past this corner here. So that fillet is going to be 2 millimeters as well. All right, so now we've added that functional fillet. The other ones are cosmetic. We're going to add a couple of anchor points here. So let's add some anchor points here to this platform. This is what's going to hold our battery box to the accessory deck. So we're gonna reference this edge here. Let's create 2 holes, 2 anchor points. Bring that in. We're gonna set these 2 anchor points so that they're equal to each other in diameter, and we're gonna set that diameter to 2.8 millimeters. And we're going to offset the location of this first hole so that it is 5 millimeters away. And we're going to drop it down by 6 millimeters. All right, so there's our first anchor point located. We're going to locate the second one in relation to the first. So we're going to set that to a distance of 24 millimeters, and we will offset it by 3 millimeters. Let's just move that constraint over so we can see it. All right. So there we are. Our 2 anchor points here are fully constrained, so we can close out of this. And because that's a 5 millimeter part, we can accept the 5 millimeter default. That will clear our hole there. Excellent. So we'll accept that. And we need to add an anchor point here. This will allow us to anchor the battery box to the vertical frame rail. So let's create a sketch on this surface here. And we're going to reference this right-hand edge. And we'll set our anchor point to 2.8 millimeters in diameter. And we're going to inset our anchor point by 6 millimeters. And then we will offset it from in the vertical by 7 millimeters. Okay, so that fully constrains that anchor point. We're going to close this and let's pad that all the way through. Give it a 10 millimeter clearance, and we'll just confirm that that went through, which it did. Okay. So now we have the left hand of our battery box. So I'm just going to rename this body here so that it is the left hand side of our battery box. And we're going to mirror this to give ourselves the right hand side. So to do that, we're going to go into the draft workbench. I'm going to turn off this grid here because I don't need it. And with my left edge selected, I'm going to click on the clone tool here. And then here in the data tab, I'm going to go to scale, and I'm going to mirror this across the y-axis with a -1. And I'm going to first rename this. And now we're going to transform this shape so that it's a little bit easier to see. So there we go. I'm going to accept that. And there is our fully completed battery box sides. We've successfully completed the structural connections between our accessory deck and the vertical frame rail and laid the groundwork for a highly rigid interlocking power module. In the next video, we're going to cap this assembly by engineering the battery box top. We'll design the 3 rectangular tabs that drop perfectly into the side sockets we just cut. To guarantee this box won't flex under heavy kinetic loads, we will also extrude custom mounting bosses on the top plate that align exactly with those upper corner screw holes, mechanically locking the entire cube together. Chart your course, build your world. See you in the next one.